On Sunday, the 27th of April, our field work began with a group gathering in front of the Geotropica 3 laboratory. From there, we set out toward Bukit Ayam in Pengerang, the site selected for our geotechnical investigation as part of the excavation and slope stability assessment project. Upon arrival at the rock slope, Professor briefed us on the field methodology, outlining the key parameters we needed to observe and record. A standardized data sheet had already been provided, containing fields for discontinuity characteristics such as dip, spacing, persistence, aperture, weathering, and more. Our first task was to establish a 5-meter scan line as a benchmark for data collection. Using a measuring tape and white rope, we carefully marked the scan line across a clean, exposed rock face. This served as our reference for all subsequent measurements. We systematically recorded all joints and discontinuities intersecting the scan line. Important details such as joint spacing, roughness, aperture, infill material, and signs of weathering or moisture were carefully documented. These parameters are critical in assessing the stability of the rock mass and predicting potential failure modes. To estimate the compressive strength of the rock surface, we used a Schmidt hammer. Multiple readings were taken along the slope and later corrected to calculate the unconfined compressive strength, which plays a vital role in the slope mass rating, SMR, calculation. After processing the collected data, we calculated a basic rock mass rating, RMR, of 62. This includes an average UCS of 56.8 MPa, an RQD of 86%, and joint spacing around 0.48 meters. With correction factors for joint orientation and excavation impact, the final SMR score was 50.55, classifying the slope as Class 3, fair rock, partially stable. Wedge failure was identified as the most probable failure mode, with recommendations including shotcrete application, rock bolts, and drainage provisions. Finally, we applied the rockfall hazard rating system to evaluate the potential impact of falling blocks on nearby infrastructure. Key factors included the slope height of 193 meters, no ditch protection, block sizes around 60 centimeters, and moderate annual rainfall. The total RHRS score was 274, placing the site in a low priority hazard category, though basic mitigation like catch fences and tow ditches is still recommended. Using StereoNet 11 software, we conducted kinematic analysis to identify the likelihood of failure modes. The slope has a dip direction of 200 degrees and an angle of 85 degrees, with an assumed friction angle of 30 degrees. The analysis revealed: 1 joint potentially susceptible to planar failure, 1 joint meeting criteria for toppling failure, and 7 intersections aligned for potential wedge failure, marking it as the most critical risk to stability. In the end, special thanks to Professor Dr. Rini and Faculty of Civil Engineering for organizing this field trip to enhance our on-field knowledge of data gathering and team working skills.